Hi everyone, good evening guys. Welcome to the second session in the master series for linear regression. I think some of the guys must have gone through the first session which we did during the same time yesterday, which is Saturday. Today we are going to discuss more on the uh, OLS technique. Why do we need to use OLS technique? What are the other possible options could have been used and why we discarded them, right? Before we get into that, let me uh, quickly have a validation on the uh, audio, video, everything. I think I would like to quickly confirm with everyone that can you hear me out? Okay. So why do we need to use OLS technique? So OLS stands for, if you recall from the last session, OLS stands for ordinary least squares. Okay, ordinary least squares. Uh, Before we get into the OLS technique, my approach would be to give you the other possible options on the table, and then tell you what are the challenges that we would have faced if we would have gone with the options. So generally, if someone if someone asks you that what are the possible options we can use, so you can see on the screen that there is a linear regression line, and then you have these data points, as you can see, the gray dots. You could have also found the horizontal distance, as you can see there, right? Or you could have also found the perpendicular distance. And as we do in linear regression, we go with the perpendicular, not perpendicular, we go with the vertical distance, right? So these are the options on the table, right? We can do horizontal, we can do perpendicular, we can do vertical distance, right? And all these options are available, but with all the options, there are some limitations. Suppose you want to compare y, right? Because y is your target variable, okay? So you want to compare the y predicted, let me write y predicted versus y actual, then measuring the horizontal distance doesn't make any sense, right guys? You agree? And same is true with the perpendicular distance as well, because if you look at this particular data point, right, you are trying to measure something which is in a direction of, let's say, if you draw the axis here, so this is your x, this is your y, correct? But you are actually measuring the distance which could inflate the actual y to a higher distance because of the 120 degree making with the x-axis. So that actually brings you on the final one, which we go with the vertical distance, because here you are trying to compare the actual with the predicted y. So if you look at the actual, this is your actual and this is what you have predicted. So you can clearly see that you are somehow getting the gap or distance between the actual and y, and later you will know that this is what we call as error or residue. Clear guys? Make sense? So now, just to sum up this discussion, what we have just done, we've gone through horizontal, perpendicular, even the vertical, and then we try to understand that horizontal cannot work, even perpendicular will not work, vertical distance is the way forward. Okay, make sense? This we have understood to evaluate the error itself. To evaluate the error, you can find error in different ways, right? Error or residues. Now, here the whole agenda is that how can we go forward and try to find the minimum error which linear regression line is going to give you when you are trying to place a linear regression line which is actually closer to all the points. But as it is, right, if you try to do that, as it sounds that, oh, it should be very easy, but it's not in true sense. Suppose you try to put a line like this, it will have different error. It will have a different error, right? Okay. So then the whole point is that how will you minimize it visually and manually? If you try to do, right, in drawing a line like this or like that or any other lines is not going to get you the optimal line, and even if you reach there it will take quite a lot of efforts. So we need to come to a mechanism which helps you to get the minimized error, and that's where we start thinking about if we start taking all the errors and try to minimize it. Okay, any question, guys? I'm looking at the chat. No? Okay, so far so good. So we try to minimize that error, and in that pursuit, if you look at, let me go down. Now I'm giving two options on the table. Can you see that, guys? So this is your option one. This is your option one. And this is your option two. It's for the same data point. You have to tell me which option is going to give you the better fit line, in terms of minimum error, right? Which option is going to give you the minimum error, means better fit line, better fit to these data points? Any ideas? Anyone? You have to do certain level of eyeballing, to be honest, right? But anybody has any ideas here? How will you go about it? So to understand that, if you want to do with the looking at the chart and the errors, right? If you start, making accumulation of the error, means adding the errors, making it positive, excuse me. So then you will start that, okay, first, before we get into that, whether we have to add the error or we have to take the modulus of the error, we have to take the square of the error. So within these two options, I'm giving you three more levels. Number one is either we'll just go and start adding the errors. Okay. That's option A. Within versus option A and 1 and 2, we have A, B, C. So adding the errors, then you can say that, okay, adding only the positive errors. Basically, I mean to say after making error positive, making errors positive, right? Now this gives you two options. Either you can take modulus to make the error positive, right? You know the mod function, mod x, or you can do what? Square, which is actually x square, right? There are few options on the table. Now, if you try to do the addition of the error, what will happen? The error which are positive, so the error, these ones, which are positive errors, will cancel the negative errors. You agree? Hello? Same is true here as well. These are the negative errors, and that will cancel the positive error. All the greens are the positive and the yellows are the negative, guys. You agree with me? Come on, keep chatting. Keep chatting. My eyes are on the chat. So if you have any question, any doubt, I can quickly look and answer. Try to interact, okay? So tell me one thing. If I start adding this, definitely it will seem that error is very negligible because error will cancel each other, right? And then what will happen? That you will get a incorrect reflection of your error, okay? Agreed? So this option is also gone out of window, right? Why? I'll also give a comment because it nullifies the error. It nullifies the error. Means cancel each other. Now let's come to the second point, which is modulus. So I'll write, if we do the modulus and then add the error, what is the issue? So suppose I take modulus, then definitely you will be taking two lines coming like this. Let me show you quickly. So if you take the modulus and add the error, you might take a look. It will look like a thin line. This is a true line coming from the data, right? For the option one, you are having this line length. This is coming from option one, guys. Come on. So if you take all the error, take the modulus and sum it up, this is how it will look like. And this guy is coming from option two. Now looking at the length, which one is giving you minimum error? Come on. Come on, tell me, guys. Option one and option two. Because what you have done, you have taken all the errors and make modulus, so negative will become positive, and then you are adding all the errors, and then you see a vertical line in option 1 and vertical line in option 2. If you compare these two errors, you can look at the length, then you can say that line 2, means option 2, has the least error. Okay, not least, less error comparing to, it has less error than option 1. So definitely, if I go on top, you will understand that out of these two lines, which line is more better line for us in terms of goodness of fit, which is a better fit line? Answer is this one, option 2. This is this error. But trust me, handling modulus is not an easy thing, because see, you're not going to draw like hundreds of lines like this, and find modulus error of the sum of modulus of error of every line, and then come to a conclusion, oh, this is the optimal uh, line for you, because here the error is the least. I think anybody would get crazy. Second issue with the modulus function is that modulus functions are non-differentiable. You ask anybody who is from any mathematics professor, they will say that handling modulus function for maxima minima is a nightmare. And I'll give you the exposure to that as well. Don't worry about it. So let me start with a little background on the modulus function. It's just like a refresher for you, those who are a little bit missing on this. So modulus function is defined as what? Mod x, and if x is greater than equal to 0, it is x, and if it is x less than 0, it is minus x. Okay, right? Now you tell me what would be the graph of this. So if you look at this, if I try to draw the graph of this function mod x, y equal to mod x, you know that when x is positive, when you are on the right hand side, you see a straight line which is going through origin like this. Correct, guys? When x is negative, which is less than 0, you will see minus x, guys. So basically, or maybe I'll use some different color, maybe blue, and then you will see that you are having mod x having two tangents at x equal to 0. And whenever you see there are two tangents, which are those tangents, guys? Come on. One is x. What is the slope for this guy? Do the slope. So slope for this is how much? Mod x dy by dx is slope. So which is going to be x 1. So slope is here 1, positive 1. And if you find slope here, it will be minus 1. So you can clearly see that you have two tangents of different slope at the same point. So then we come to conclusion, and if you have done a little bit of mathematics, like with respect to calculus, you would know that, I'll give a statement, that mod of x is non-differentiable function, means you cannot differentiate, and in this case it is non-differentiable at x equal to 0. So whenever you get that corner shape, right, can you see that there is a corner? Let me highlight. This part is known as corner. Whenever you look at any modulus function, it is like having a corner. All these points are non-differentiable. And if it is non-differentiable, how will you use maximum minimum? Because end of the day, ordinary least square technique relies heavily on minimizing the error to minimize the error, you have to deploy maximum minimum concept from calculus. And if you are modeling that error as a modulus function or the sum of the modulus of errors, you are not going to proceed further. Make sense, guys? I'll take a pause here. Any question? No? So then what are we left with? Then we have to go with what? Then we have to go with what? Ordinary least square method, which is relying on the square of errors, right? So the moment you do squares of error, things will change a little bit. Let me show you on the screen. So when you do square of error, let me show you this for the same data point. And now you are going to take the square of the error. What will happen? Equivalently, I'll put it on the right hand side, guys. These are some really nice screenshot. Credit goes to the author, and we are just leveraging for our learning, right? And we give credit to the people who have worked on this. So when you are trying to do the square means what? You will take the length, right? And you will take the square, right? Square means what? Let's understand. If you pick any one of this, let's say you want to pick this guy, right? If you want to do square of this error, means what? You are talking about the square itself. Guys, that's what you will see on the right hand side. See, I'll give an example. This is your what value? This is your y hat. And this is what? The grayish, I'll make it black. This is what? Y actual. So y hat is y predicted, guys, okay? Predicted. Now you tell me if I want to find the square of the error, I have to subtract actual minus predicted. Do the maths. So this error, let's say this error is epsilon. Just hypothetically, you say epsilon. It will be what? Y actual minus y predicted. Simple. Now, whatever it is, whether it is positive or not, you are going to do the square. So this is your error. Now you will do error square. So it will become what? Y actual minus y predicted, and you're doing square of this distance. So what is if you take on a simple square, a square box, right? AA, what is the area of a square, guys? Come on. Everyone. What is the area of square? Area of square is A square. Isn't it, guys? Come on. This must have been done in school days, class 9, 10, mensuration, right? So then here, if you look at the linear regression, correct, guys? This distance, whatever the distance, the blue distance, right? The gap is actually converted into a box. Can you see that on the right hand side? Now we are going to take all the area and add it up. So this will look like this, and you will love it. So I am going to take all the boxes. I'll show you here just below that. See, our aim would be to take this sum total, which is actually what? Which is sum of squares of error, and then we will try in linear regression model or algorithm minimize this error. This is what OLS does for you. Bring it down, bring it down. This is, in simple term, we call OLS technique. In one line, if I have to explain, this is what we call as ordinary least square method or technique. Are we clear, guys? So far, so good. So if you observe, you will realize that earlier I was trying to look at a line when I was doing modulus sum, right? Sum of modulus of error. It was all line, straight line. Definitely it goes from line to a two dimension where you are looking at the area, which is a square. But this is more easy to handle because modulus functions are non-differentiable. You cannot deploy the maximum minimum concept, and minimizing the error will be a tussle there, right? It's very tough. Then you have to, do n number of combinations of all the lines take the modulus distance of the errors and sum it up and find the minimum error. Here, you don't need to do all combination. You just take a mathematical formulation, which I'll do in some time, and get to the coefficient, beta naught and beta 1. Make sense? So far so good. This is really beautiful, right? Look at that, how we have moved. Starting from, we can evaluate errors in different ways, right? Just to conclude the whole discussion, we started with horizontal distance, we moved on to the perpendicular distance, and I answered that why not horizontal. And if you have missed the session a little bit, right? Why not? I have answered. Why not perpendicular? I have answered. Why vertical? That I have also answered. Once you have the vertical, then we get into that. Are we going to do the just simple sum of the errors? Answer is no. If you do just simple sum of the errors, what will happen? Error will tend to nullify each other and you will be incorrectly capturing the errors in the model. Then what is the solution for that? Then you think, okay, we have to take the error. Even if it is negative, we'll take it positive. So the quick idea or the intuitive idea comes to your head. Oh, we'll make it modulus of the error to make it positive. Then modulus poses another threat to us. Not like threat. I think this is some really deep one, but more like challenge to our problem, right? That modulus cannot be applied with maximum minimum concept is very difficult. I explained quickly that, and then I came up with the concept of square of the error, which actually moves it from the line to area. As you can see the boxes, and we'll take all the boxes, sum it up, and minimize the error. Does it make sense, guys? So this answers the ever pending question. Generally, I think if you really want to get into the depth of linear regression, this should be your approach. And I think, Aditya, if you recall, we were discussing yesterday that you have used gradient descent algorithm. So as we proceed further, once I'm done with OLS, I'll move to the gradient descent as well. I think that will be the last session where I'll show you the concept of learning rate, which is alpha, right? How do you handle the learning rate, and and what are the best practices when we are going to do it in Python. So looking forward, I think upcoming 2 more sessions, which will happen next week, it is going to be like really interesting, and it will provide you amazing perspectives on linear regression. We are targeting here simple linear regression only, guys. Okay, so today I think I will derive the linear regression beta naught beta 1. That will be next part of the today's session, which I am going to start. But before I get into the detail again, I would like to inform our new friends, right? So my name is Akash, right? Some of the guys might have seen me yesterday. I'm an IIT Kanpur alumnus, currently working as a lead data scientist with Accenture Strategy Consulting. I have been teaching for GATE for last, somewhere 14-15 years. I was teaching electronics, and now a DA paper has come, so my industry experience in data science, applying in multiple projects over a period of 8 years, and then GATE experience combinedly. I'm trying to give you the best on GATE DA preparation, right? GATE paper, which has newly introduced, if you're not aware. And if I can quickly go back to the description of the, if you go back to the your YouTube channel, right, where you will see there is, linear regression part 2, which you are currently watching. You will see in the description there are 2 or 3 links where, guys, you can go and click to understand more about the program. So as we speak, I have already, I think we started almost 1.5 months back teaching for the GATE DA paper, targeting 2024 as well as the next year. So this is a golden opportunity. I would like to take a moment to explain that why GATE DA paper, which has newly introduced, can change the way you are looking at your career. It's not only for the GATE paper I am trying to promote or trying to encourage you guys to prepare for. Even if you are really serious about data science as a career choice for you, and why not? It means data science has the almost the highest opportunity in terms of job openings or the salary growth or the kind of challenging work, and interesting as well. I have spent quite a few years. I can vouch for that. So that's where I think, even if you're preparing for GATE, for doing masters or getting into PSU jobs, or later on you just want to do a job in data science field after your BTech, or or you are already a graduate, it is going to be a good choice, right? So I would like to take a moment to at least explore the program. Click on the link, Notes will be shared after, I think, Monday or Tuesday. So once we complete today's session in the series, it will be shared in this Telegram group. So I hope some of the guys who are there in the session, they might have joined this Telegram group, guys. You don't need to ask me. You can just look at the description. You will find it. Okay? Make sense? Cool. Let me go back to OLS derivation. Any question from anybody? I will open, quick 2-3 minutes for questions before I start getting into the derivation. I'm looking at the chat. Aditya, anyone else? Any question? No? Okay, let's get started. So, guys, I will do the derivation for the OLS technique, right? So, let me start with it. Sorry. Okay, if you see, you will be seeing that I've given you the nice diagram there, right, guys? Okay, and you can see that the green line is your linear regression line, the blue dots are your data points, right? And then if you look at, we are trying to estimate beta naught and beta 1. Okay, so I think you guys are already aware what is OLS. I explained really nicely, but I would like to give a definition as well, more like a textbook definition. Okay, so if I write OLS is an optimization strategy that allows to find a straight line that is as close as possible to data points, right? I'm just jotting it down so that it's with you on the notebook. In a linear regression model, that's the whole plan. See, what is your whole plan when you're doing a linear regression model? You're trying to minimize the error, which basically means in simple terms that a line which you can find which is as close as possible to the data points, which have been telling multiple times, right? Now we need to do derivation. So I'll start with my formulation. So I'll say yi, please pay attention, guys. I'll go slow. Alpha plus beta xi plus ei. You might have seen me using here beta naught. So see, guys, there's not much difference. Sometimes I say alpha beta, sometimes I'll say beta naught beta 1. Even the other authors will talk in different textbook or literature. They'll say beta beta naught, alpha beta, a and b. So these are some interchangeable coefficient names, right? Some of the authors will say ab, some other authors will say alpha beta, some will say beta and beta naught. This is all valid nomenclature for simple linear regression. So don't feel we are moving away in terms of notation. It's the same thing. Okay. Now you know that here you have a EI or epsilon I. This is known as your error term. Error term. Correct? And you know that if you put xi equal to 0, let me write, putting xi equal to 0, what will happen, guys? Yi will become what? Alpha. Basically, this is your intercept. So whenever you make the independent variable 0, that gives you the intercept. Are we clear, guys? That gives you the intercept. Hello? Right? Now, if you make intercept 0, putting alpha 0, and if you write yi, and also assume that error is not there, so you will write yi equal to beta xi. So basically here you can see that yi by xi is your slope, and slope is equal to beta. Right? Clear, Aditya? Everyone? Now, if you increase xi by, let's say, 1 unit, I'm just giving an idea here. If you increase xi by 1 unit, by 1 unit change, right? Isn't it yi will also increase by same? Hello? That's the whole point here, guys. Come on. If it is directly related, right? If it is directly related, so increasing xi with 1 unit, your yi will increase by, that 1 unit will make it increase by beta into 1, is beta units, right? Hello. Sorry, my bad. So when I said yi equal to 1 unit, I meant 1 into beta. So it will increase by that beta. Now, guys, you know a little bit of what is mean and all. I'll just quickly refresh your memory. So what is mean? Mean, you know the formula, right? X bar or mu. It is written as what? Sigma xi. So you'll take all the observation, add it up, and divide by n. Right? That comes as mean. Okay. And then somebody can also be using variance. So what is variance? Variance is v of x is equal to what? Squared deviation. So you will take mean and subtract from xi and take I equal to 1 to n, sum of squares of deviation from the mean, and divide by average. And the last thing will be standard deviation, which is square root of variance, denoted by sigma x, and it will be root under, please pay attention, xi minus x bar whole square, I equal to 1 to n, divide by n. This is under root. Let me put a different color there. Perfect? Clear? So now if you look at this, these are some basic statistics formula, right? Coming from descriptive statistics. So if you are good with some of these things, because I'm going to use it, so then I think we are cool, right? We can start with the formulation. So you know that yi is alpha plus beta xi. This thing is, guys, known as yi hat. Right? This is your predicted. And the y on the left hand side, my dear, what is that? That is your actual. Correct? So if you take error, what will be the error? If you take the difference between these two guys, that will become error. Come on. What is error or residue? Error or residue is, excuse me, is equal to what? Yi actual minus predicted. See? And definitely this is your error. You are going to do the square and everything, that you know that. So if you try to find the error function, that becomes what? S. You will take all the yi and yi hat. You'll do the square, sum of squares of error, and then you will do a sigma to sum all the error I equal to 1 to n. Are we clear, guys, for all the n data points, right? Later on, you will only go and write that this sigma I equal to 1 to n yi, and yi hat can be replaced with alpha minus beta xi whole square, right, guys? Excuse me. And I can put a box here to say that what you are looking at is known as error function, or S, or error function. Now our job is to minimize this error function, isn't it, guys? Come on. Our job is to minimize this error function. Am I making sense, guys? Come on. How will you minimize this? To minimize, you have to use, to minimize the S function, what we have to do, we have to either write del S by del alpha equated to 0, right? So you're going to minimize with respect to alpha and beta, right? Remember that you need to find these. These are your variables. And then we have to write del S by del beta. These are partial derivative, guys. And you have to make it equal to 0. Okay? So now, if you look at the simple maths, it's very easy, because if you take this S, now I'll start with, calculate del S by del alpha and put it equal to 0. That's my starting point. So I'll rewrite my equation of S, which is, sigma. Now, guys, I'll do some changes in the way we write here. I equal to 1 to n, I'll not write. It's understood. Okay? So be smart. Y minus alpha minus beta x. So what is the only change I have done, my dear, here? I have dropped the I. For the sake of convenience. Oh, this is a feeble font. Sorry. Dropped I for convenience. Don't think I is not there. Hello? So dropped I for convenience. Keep this in your head. So now you see, what I'm going to do, I'm going to partially differentiate. This should be very easy for me with respect to alpha. So now, as per the concept of differentiation, you have to apply chain rule. So then this whole thing will become what? You have to understand also. This will become 2 times, then there will be a sigma, and you'll write it as it is, y minus alpha minus beta x. See? And I hope everybody knows this kind of baby differentiation. Suppose I say, what is d of x square with respect to, x is what? 2 times x. So you can clearly see that this 2 comes here. Similarly, this 2 will come here. And then you will write as it is everything. And then you will get into the chain rule. You also do chain rule here. You will write dx by dx, which is actually 1. You will also do here d by d alpha of what? Y minus alpha minus beta x. Did you understand, guys? And you can put another cool bracket here. Everybody, this is real maths we are doing. I'm not just shying away from deriving the answer, deriving the results, okay? And without that, you cannot survive, trust me, for the GATE paper. So 2 sigma, let me write, y minus alpha minus beta x. And if you do with respect to alpha, so the moment you do with respect to alpha, these two guys, y and beta x, all are constant, my dear. Can I say that? When you are differentiating with respect to alpha, these are treated as what? In partial derivative, constant now. So what will happen? You will just take it as constant. Constant differentiation is 0. So then it will be what? 0 minus 1 minus 0. Super easy. So ds by d alpha is how much? This minus will come out. Minus 2 sigma y minus alpha minus beta x. Then you operate the sigma, guys. It will become what? Minus 2. See, before you operate the sigma, why don't you just make it equal to 0? Because the end objective is to make it equal to 0. So then finally it will become what? Sigma y minus alpha minus beta x equal to 0. If you do the math, it will be sigma y. And now I'll bring I equal to 1 to n. Can you see that, guys? I know it's convenient for me, but that's how you will be doing it fast. Minus, you will do what? Alpha I equal to 1 to n minus beta can come out because beta is constant here. You will write xi I equal to 1 to n equal to 0. So far so good, guys. I'll take a pause here. Aditya, and anyone who is live with me, can you see that? Are you making sense out of it? Then in the next step, I'll take this guy on the right hand side. So it will become alpha I equal to 1 to n equal to sigma I equal to 1 to n minus sigma beta I equal to 1 to n. See that? Now you know that if you are doing alpha addition, n times, right? What is the interpretation of this? You are adding alpha how many times? Adding alpha n times, right? That's what is mean. That's what it does mean, right? So then you will write alpha times n equal to what? yi sigma I equal to 1 to n minus beta I equal to 1 to n, right? So the final result will become, for the alpha will come out to be what, my dear? You know that if you take yi and do sigma I equal to 1 to n and then divide by n also, it becomes yi average, right guys? Minus beta times sigma I equal to 1 to n and divide by n. Now you know that these guys will become average, because that's why I told you what is the formula of average, right? So if you see, this guy is becoming what? This guy is becoming yi bar. Similarly, this guy is becoming what? Come on. It is becoming xi bar. So far with me, guys, come on. So finally, you can write the result for alpha equal to yi bar. Take all the actual of y values, do the average. Take all the input xi's, take the average and multiply with b. This is your first formula which we have derived for you. So far with me, guys, come on. That's how you estimate alpha. I'll take a pause here. And this is after calculating ds by d alpha, which actually helps you to, finding alpha. Good. Clear? Perfect. We are almost there. Now we are going to calculate ds by, means actually it is del s by del beta equal to 0. And this will help us to finding beta. You agree, guys? Come on. So let's get ahead on this. So now again I'll write what is my s. So s is equal to sigma yi minus alpha minus beta xi, and I is going from 1 to n equal to whole square. Perfect, guys. To make it simple for everybody, what I always do, I call this guy as what? U square. So I'll call this internal guy as u. So this can be written as what? I'll drop sigma I now. It will be written as simple u square. So now if you differentiate del s by del beta equal to 0, so then it can be written as what? Del s by del beta can be written as, by chain rule, del s by del u into del u by del beta. Listen it, guys, come on. That's how chain rule works. So del s by del beta can be written as, for this guy, as 2 times sigma u, right? Correct? And then it will be what? Del u by del beta. Now you know that what is your u. So you'll write del s by del beta equal to 2 times, and what is your sigma u? Guys, your u is what? This is your u, the yellow region. So it will be y minus alpha minus beta x, and then you have to do partial differentiation of this with respect to beta. It's the same thing which you have done it, guys. Now this time, which ones are the constant? Alpha, y. These are the constant. Keep in your head. And constant differentiation is 0. So what you will write? You'll write del s by del beta 2 sigma y minus alpha minus beta x. And now if you differentiate with respect to del beta, then this is 0, 0, 0 minus x. Guys, can you see that? And then you will also make it equal to 0. Now, if you do the maths, it's very simple. It can be written as, now this minus is gone. Let me write one more step, else it will be injustice for you. Minus 2 times, now multiply x, xy alpha x minus beta x square. This is what you see. Now put it equal to 0. So then your equation becomes sigma I equal to 1 to n xi yi minus alpha xi minus beta xi whole square, isn't it? And put it equal to 0. Then obviously you will open it up, because you have to also use alpha to an extent, right guys? You have to open it up. So you will say that, and that's where you have to be very careful. You will apply this summation very carefully. Xi, yi, I equal to 1 to n. It will go for these two. So this is like product of x and y and then sum it up. Minus it will be alpha. Now here you have to bring alpha. What is the alpha we had estimated? Hello? Guys, what is alpha? Yi minus beta xi bar, right? Yi bar. So it will be written as yi bar minus beta xi bar. Agree? What I'll do now, I'll change the color for this guy so that it looks different. Perfect. Now this whole thing is your alpha, and then you will do xi, and don't miss this sigma. Sigma is sitting outside. Okay. Minus beta sigma xi whole square, right, equal to 0. I'll take a pause, guys, because this is really tricky and you have to be careful. Give me a go ahead if you are done, if you are able to follow this. I know this is some real mathematics. We are doing some serious business we are dealing with, but you should be able to handle it. Go through it again. This is a video, so you can always watch as many times as you want. Perfect. This is good, guys. Now what I'll do, now if you look at here, this is a very simple mathematics. See, this is your xi, yi, I equal to 1 to n. Then this is what? It is going from I equal to 1 to n. So this will be how much? Yi bar is already your average value. So you have to come it out, right? Bring it out. And this is what? Sigma xi I equal to 1 to n. Right, guys? I'm combining these two guys. Let me also use some color coding. If you combine yi bar is already a constant. So it will be like this. Okay, this is minus. And then you will do plus, minus, minus, plus. And then it will what? Beta xi coming out, and this will be xi bar, sorry, xi I equal to 1 to n. See the maths, guys. Okay, and then it is how much? Beta, I missed to write here I equal to 1 to n. I equal to 1 to n xi whole square equal to zeta. Now you are looking at so many terms, guys, okay? But you can do something about it. And how can you do it? I'll also explain. Any question here? No, right? So how can you do it, guys? Here you have to combine this. Xi, yi, right? Yi bar is there. And then you have to have, this sigma. So what you can do actually, hold on. Any question? No, right? Now you know that. Let me come back. What is y bar? So y bar is what? Yi, sum it up, I equal to 1 to n, and divided by n. So then it mathematically becomes what? Right? Nyi bar can be written yi equal to 1 to n. Guys, come on. This is a very beautiful manipulation I'm going to do. So what I'm saying that is, this yi bar, if I multiply with n, can be written something else or not, guys, right? See, what is, or on the other hand, if you look at this, I equal to 1 to n xi, so I can do something about it, right? So there, if you do this, excuse me. So there you want to do some manipulation. So what will happen? I'll do the manipulation. I'll divide by n, okay? I'll divide by n. Maybe I'll just combine first. Okay, hold on. I'm just also thinking, I'm improvising, guys. So I'll divide by n later, but let me first group it. So if I group it, I'll say xi, yi, right? Minus, you know, yi bar xi, and I'm combining the summation. Which summation, guys? I've combined this summation and this summation into one outside. So I'm taking a step back, right? Can I combine these two, guys? Focus on the two terms and tell me if I can do this or not. Okay? And then on the right hand side, I'll write beta, and then again combine these two other guys. I equal to 1 to n. I'll write xi whole square minus xi bar xi. So what is this I have combined? These two guys I have taken on the right hand side and I have combined again. So far so good, guys. Everybody's clear? Give me a go ahead. Now what I'm gonna do, I'm going to replace few of the terms and then you will realize. Okay. So now if you see yi is equal to what? Any question? No, right? So if you see, if I take this beta equal to, and I divide it by what? Sigma xi yi minus yi bar xi I equal to 1 to n, and divide by what? Sigma I equal to 1 to n xi I square xi bar xi, right? Now what I'm going to do, I'm going to multiply n on the top and in the bottom. Hello, guys? And there is an intention of doing it, right? Why I'm doing it, there's an intention behind it. Okay? If I multiply this n here and then I start getting into the final formula, see guys, so my final formula becomes n times, this term will get multiplied, it will be product of xi, yi, and then you will also sum it up, right? I equal to 1 to n. Minus, here if you write sigma xi, and if you write yi bar times n, this I'm going to substitute it with, let me show you. Ta-da! See guys, can you see this? So NYI bar can be replaced with I equal to 1 to n. Isn't it, guys? Come on, give me a go ahead on this. Clear? So then this will be getting replaced. I'll do it in here only. So I'll just take this out. I'll say sigma xi, sigma yi, I equal to 1 to n. Can you see that? It is individual sum divided by, similar thing we'll do. You'll write n times xi square I equal to 1 to n minus, again it will become what? Xi sigma xi I equal to 1 to n, and this n xi bar will become what? Again sigma xi I equal to 1 to n. So you realize that, and in the final formula, guys, you'll realize that it is, I'll drop now I again. So you'll realize that beta is equal to n times sigma xy product minus sigma x sigma y divided by n times sigma x square minus sigma x whole square. I know that this is little lengthy formula, but I had to do it in this session. And always remember that I is running from 1 to n. Don't miss that. This is definitely a lengthy derivation, but we need to do derivation. And what was alpha, my dear? Alpha is y bar minus beta x bar. Keep this in mind. So you know the alpha, you know the beta. Later on, this will be also written in some formula, some techniques like covariance and other stuff. So don't worry about it. But I think this is where I stop for the day, right? This series session 2, part 2 linear regression. I hope you were able to understand the mathematics behind it, how we have calculated alpha and beta. We really did spend quality time in getting into the whole derivation, right? End-to-end derivation. We are not in writing anything directly there or using some results. I'm coming to alpha beta. Later on, this can be shown on an Excel. So what I'll do, maybe in the next session, I will use Excel to prove it. Later on, I'll do it in Python, where I'll be using a scikit library to demonstrate how we can code in Python and build a quick model linear regression or simple linear regression model. That will be the last session, and then I'll also show you quickly how gradient descent algorithm works there. So that's definitely a promise to you guys. Again, thanks for joining the session today. Keep coming, keep supporting us. That's very important. End of the day, we are trying to do something for you, uh, more like given to the kind of open community for the GATE DA aspirants. And if you're interested in the program, as I've highlighted many a times, go back to the description, come down to the description in the video. Those who are going to watch this session later as well, and click on the program to understand more about the program. You want to understand more about me, you can always go and search me on LinkedIn. You can easily find my name, and we can always have a discussion if you need. So on this note, guys, thank you very much. Notes will be uploaded somewhere. I think Monday and Tuesday. Give us some time. Notes will be pushed into the Telegram. Thank you once again, guys. Happy learning and have a good start of the week. Thank you very much. Take care.